This is a video walkthrough for the Unit 3 review Part 1, which is the non-calculator part. In numbers 1 through 3, we're asked to solve the system using the specified method. Make sure that you know which specified method to use. The graphing method means that we will solve by graphing the two equations. So I'm going to take each of my equations and rewrite them in y equals mx plus b form. So we're going to subtract 3x and then divide through by -1. That's a line with a y-intercept of -9 and a slope of 3, or 3 over 1. So rise 3, run 1, positive slope, moves upward as you go from left to right. And then let's take our second equation, which is x plus 2y is equal to -4, and subtract x from both sides, and then divide by 2, and that gives us y equals -1/2 x minus 2. Y-intercept of -2 and a slope of -1/2, which means down 1, right 2, or up 1, left 2. And then don't forget that we still need to give the solution, and the solution is that intersection point, which is the point 2, -3. The next system, we're requested to solve this one by the substitution method. I like to use the two-column approach for the substitution method. 2x is equal to y plus 9 is one of the equations. And then my second equation is 3 times y is equal to 2 times x minus 19. And we need to investigate which one of these equations would be easy to solve and for what variable. And since we have a 1 times y in that first equation, the first equation would be the easiest to solve for y. So I'm going to subtract 9 from both sides, and 2x minus 9 is equal to y. Now I'm going to take that information and I'm going to replace the y in the second equation with 2x minus 9. Let me bring down the rest of the equation. 3 times the y value, which is 2x minus 9, is equal to 2x minus 19. Let's distribute the multiplication over the subtraction, and then subtract 2x from both sides, and then add 27, and dividing by 4 we get x is equal to 2. Now I'm going to take that information and go back to the first column, or the first equation, and replace the x with 2, and that will allow us to solve for y. That gives us 4 minus 9 is equal to y, or -5 is equal to y. Don't forget to write that in ordered pair form, 2, -5 with parentheses. All right, in 3 we're asked to use the elimination method. So I'm going to start by rewriting these equations in standard form. The first one is not in standard form, but can be easily written in standard form by subtracting 1 from both sides. And then we can take and multiply equation number 1 by -1. That will allow us to have a coefficient of y that's the opposite of the coefficient in the second equation. So -2x minus 3y is equal to +1, and then I'll bring over that second equation, 5x plus 3y is equal to 29. Adding the two equations together, we get 3x is equal to 30, so x is equal to 10. And then I'm going to take my first equation, doesn't matter which one you use, and I'm going to replace the x with 10. And that will give us 20 plus 3y is equal to -1. Subtracting 20, that will give us a y value of -7. So our ordered pair solution is 10, -7, written in ordered pair form. In numbers 4 through 8, we can use the algebraic method of our choice. That means a method other than graphing. So I'm going to use the substitution method on this one, and the reason I'm using the substitution method is this first equation looks like one that would be easy to solve for x. So just adding 6y to both sides, x is equal to 6y plus 9. Now I'm going to bring over the second equation in my second column, and I'm going to replace the x with that 6y plus 9. So I'm just putting a parentheses where the x was, and then filling that parentheses with 6 times y plus 9. Now we have an equation with a single variable, distributing the multiplication over the addition in the parentheses. Now we have 33 times y plus 36 is equal to 14, and subtracting 36, that would give us negative 22, and dividing by 33, that's negative 22 33rds, which is negative 2/3. Let's take that information and go back to our first equation. So the first equation, x is equal to 6 times the y value plus 9, where the y value is negative 2/3. 6 times negative 2/3 is negative 4. Negative 4 plus 9 is 5. So our ordered pair solution is 5, negative 2/3. Now let's take a look at number 5. This one I'm going to just rewrite in standard form. So I'm going to take this equation here, and I'm just going to add x to both sides. So 9 is equal to x plus 3y. Now both equations are in standard form. So I have 4x plus 12y is equal to 32. And let's take this equation and let's multiply through by negative 4. That will allow us to eliminate the x's. Negative 4x minus 12y is equal to negative 36. Let's add those two equations together. On the left we get 0, and on the right we get negative 4. And so 0 is equal to negative 4 is a statement that is never true. That means that there is no solution to this system. In number 6, we have two equations that, again, can be easy to write in standard form. And by standard form, I just mean ax plus by is equal to c. We don't have to have integer values for those, nor does the a value have to be positive in order to use this method. So I'm going to keep the first equation, which is already in standard form, and then subtract 6x from both sides for the second equation. And then let's take and multiply the first equation by 2, and that will accomplish opposite x coefficients. So 6x minus 2y is equal to 14, and I'll just bring over the second equation. And when we add these two equations together, we get 0 on the left and 0 on the right. That is always true. That means that there's an infinite number of solutions, but we still need to give our general solution. And so our general solution will always be an ordered pair x, and now we need what y is. Let's take this first equation here and solve this equation for y by subtracting 3x and dividing by negative 1. And the y value is always equal to 3 times x minus 7. And there is our general solution for an equation that has an infinite number of solutions. For number 7, I think I want to address the fractions first. It will probably be easier for us if we just clear fractions from both equations. The first equation has a least common denominator of 6. Multiplying through by 6, we get 4x plus 3y is equal to 15. And then multiplying the second equation through by the least common denominator of 5 gives us 2x minus 5 times y is equal to 1. We can now multiply again to get opposite coefficients. So I'm going to multiply that second equation by negative 2. and bring over the first one. 4 times x plus 3 times y is equal to 15. And multiplying through on the second equation gives us negative 4x plus 10y is equal to negative 2. Adding 13 times y is equal to 13. So that gives us a y value of 1. Let's take either of the first two equations. So let's just use this one right here. 2 times x minus 5 times 1 is equal to 1. So that's 2x minus 5 is equal to 1. Adding 5, 2x is equal to 6, and dividing by 2, x is 3. That gives us an ordered pair for the solution of 3, 1. In number 7, our equations are a little messy. Let's clean them up first. So let's take this first equation, 3x minus y plus 1 equals 2x plus 1. I'm going to distribute the multiplication by negative 1 to the parentheses on the left, and then subtract 2x, and finally add 1. So now we have x minus y is equal to 2. And then I'm going to take the second equation, which is 2 times x minus 3 equals 26 minus 5y. Distribute the multiplication. And add 5y to both sides. And now add 6. And now we have two equations that are in standard form. I'm going to recopy the equations over on the other side. So x minus y is equal to 2, and 2x plus 5y is equal to 32. Let's take and multiply the first equation by negative 2. That will allow us to add the equations together and cancel those x variables. Negative 2x plus 2y is equal to negative 4, and add that to 2x plus 5y is equal to 32. Adding together, we get 7 times y is equal to 28, and y is 4. I'm going to take that equation, x minus y is equal to 2, and replace the y with 4. And we get x is equal to 6, so our ordered pair solution is 6, 4. In 9 through 11, we're to graph the solution set for each system of inequalities. So I'm going to take 3x minus 2y is less than 0, and solve that for y. So subtract 3x from both sides, and then divide by negative 2, which changes the direction of that inequality. So y is greater than 3/2 times x. That has the boundary line has a y-intercept of 0 and a slope of 3/2. So I'm going to mark off some points that lie on that line. That line is dashed because there is not an or equal to, so the solution does not include the line, only the points on either side of the line, on one side of the line. And then our second inequality is already solved for y. Y is less than or equal to 1/3 x plus 4. That line, boundary line, has a y-intercept of 4 and a slope of positive 1/3. So we're going to go right 3 and up 1. And that gets a solid line since the line is included in the solution. And now what we want to do is we want to shade below that second line since y is less than, and above the first line. So below that second line and above the first line would be the region right here. So we're going to shade that area in, and that will be our solution set right there. Now let's look at the system in number 10, which has 3 inequalities. Let's take the first one. 2x minus y is less than or equal to 2. I'm going to solve it for y. So subtract 2x from both sides, and now divide through by -1, which changes the direction of the inequality. The boundary line has a y-intercept of -2 and a slope of 2. And the boundary line is included. So we'll make it solid. We do want to graph above that line, so I'll make a little notation here that we're going to shade above that line. And then our next inequality, x is greater than or equal to -5, is the boundary line is a vertical line, x equals -5. I'll make that a solid line. And then y is less than, oh, and by the way, we're going to shade on the right side of that since x is greater than, the greater x values can be found to the right. And then the last boundary line here is y is less than or equal to 2. Y equals 2 is a horizontal line. And since that's less than, we'll find y values that are less than below. So we're going to shade above the first line, below the horizontal line to the right of the vertical line. So that shading will be this area right here. That's above the oblique line, below the horizontal, and to the right of the vertical line. Our last system of inequalities to graph has an absolute value boundary. So this is an absolute value boundary that has a new origin of 1, 2. So 1, 2 is right there, and the negative before the absolute value indicates that this absolute value V shape is opening down. You can create a table of values if you like. Since this is or equal to, we're going to include the boundary line, which means that it'll be solid. And so we have this V shape here. Its y is greater than, so that indicates that we're going to be shading upward. Now let's graph the other boundary. This one will need to be solved for y. So subtract x and divide by -3, which reverses the inequality. And that gives us y is greater than 1/3 times x minus 1. That has a y-intercept of -1 and a slope of 1/3. So this boundary is a line. This would be a dashed line because this inequality does not have or equal to. And we're shading above that V shape, and we are also shading above that line. So above the V shape and above the line would be the area on the top of both. So let's shade that area in. My pen's not cooperating here. So that would be everything that's above both of these. And there's our solution to that system of inequalities. For number 12, we're asked to rewrite the system of equations that's represented by the augmented matrix and solve the system. This is without a calculator. And the reason why it's without a calculator is it's a fairly simple system to solve. So our first equation is 0x plus 0y plus 3z is equal to 18. That's just 3z is equal to 18, so that means z is 6. And then our second equation, 5x plus 0y plus 0z is equal to -20. That's just 5 times x is equal to -20, so x is -4. And the last equation, 0x plus 4y plus 0z is equal to 28. And that's just 4y is equal to 28, so y is equal to 7. And so when you write this in ordered triple form, don't forget it has to be in order. X is -4, Y is 7, and Z is 6. And that's the solution to our system of equations. And you can write the system without the 0 coefficients in there if that makes it easier. Just 3z equals 18, 5x equals -20, and 4y is equal to 28 are the three equations. Our last exercise here is to solve a system without a calculator and write the solution in ordered triple form. So what we're going to do is we're going to eliminate the same variable twice using different pairs of equations. The very first equation I'll use is pair of equations is 1 and 2. So using equations 1 and 2, x plus y minus 2z is equal to 7, and negative x plus 4y plus 3z is equal to 2. Adding those two together, the reason I chose them is because the x coefficients are opposite, so that makes it easy to eliminate x. 5y plus z is equal to 9. And now I'm going to take and use equations 2 and 3 and eliminate the exact same variable. So on doing so, though, I'm going to take equation 2 and multiply it by 2. So 2 times equation 2, negative 2x plus 8 times y plus 6 times z is equal to 4. And equation 3 as is, 2x minus 3y plus 2z is equal to negative 2. Adding those together, we get 5x plus 8 times z is equal to 2. I'm sorry, that's 5 times y plus 8 times z is equal to 2. You'll notice that in equations 4 and 5, the ones we just created, that both contain a coefficient of 5y. So let's take equation 4 and multiply it by negative 1. So negative 1 times equation number 4 gives us negative 5y plus, or rather negative 5y minus z equals negative 9. And then equation number 5 as is, 5y plus 8 times z is equal to 2. Adding those together, we get 7 times z is equal to negative 7, and so z is negative 1. Now let's take equation number 4 and replace the z with negative 1. That gives us 5 times y is equal to 10, or y is 2. And now we can take and replace y and z with those values in the one of the first equations. So let's go back up to one of the first equations. I'll just pick number 1, and we're replacing y with 2. And z with negative 1. So that's x minus 2 plus 2 is equal to 7, and that's going to give us an x equal to 7 when we simplify. So in ordered triple form, our solution is 7, comma, 2, comma, negative 1. And now I'm going to correct my careless error. When I replaced y and z, I did so inaccurately, so my solution did not check. Let me change that. So our y value was 2, not negative 2, that's what I did. And so now we have x plus 2 is equal to 7, and the solution for x is 3, so I'm going to change my order triple to 3, comma, 2, comma, negative 1. And that's it for part 1.